I'm currently the president of the VideoLAN project, which is now a non-profit organization based in France. And I'm one of the lead developers of a VLC media player, one of the core three guys. So if you don't know VLC media player is an open source media player whose symbol is a famous cone and who's been starting a long time ago. So it's a very funny story. The reason why you have VLC is because the guys who were living on the École Centrale Paris campus wanted a faster network to play Quake. As the school did not want to pay for the network, they had to ask a lot around how they could have a new network, and there was one guy from TF1, the major France network, who said, okay, so if you can kill your network and push the new DVB satellite streams directly to your network, we were in 1995, I pay you a new network. So the older network was a token ring network, so if you ever played Quake or any other stuff, it really sucks. So at that time, so it was like 1995, your Pentium did not have MMX, decoding on MPEG-1 stream was just like unbelievable, but they did it anyway. And that's how the VideoLAN project started, who made a lot of stuff. VLC is one of the most known one, but there is also X264, which is a major encoder ever used. And so today I'm going to do a different talk than usually, but I'm going to explore why did VLC succeed that much? What are the technical reasons why this went so good? I mean, media players, they have a lot of them, and VLC is also open source, so all the codecs are there. Why don't you guys use another software? And in fact, VLC today is around 900,000 downloads per day, and that's more than 1.3 billion downloads since we started counting, which is around 2007. It's on 1 every 6 Mac, and it's in the top third-party program run on Windows. Not only download, but also run. And of course, a lot of downloads are not counted because it's open source, so you can redistribute. We don't count Linux, we don't count download.com, and so on. And it's also funny because we are here. It's the most used French program around. It's probably also the one that makes less money compared to the to the user base. Anyway. Of course, everything we do is open source. We are volunteers working on our free time, on my all nights and weekends, and so on. So, so we're here for a very good reason, which is so you geeks and you understand hacks. So why is VLC so popular? And what helped becoming it popular? We all know the social reasons, or if you don't, well, refer to my other talks. But why technically? I mean, we must have done something good, right? Well, we hope. There are three main reasons. The main reason is modules, how VLC architecture works. I'm going to explain why. C++, or C++, or objective, no, C object, not Objective-C. And the network-oriented, which was at the birth of VLC. All those three main ideas came in when the project rebooted in 1998. After they got the money and the new network from TF1, they started to, okay, we work great, let's redo it. And they had those main ideas. And I'm going to explain those three main ideas and why it helped. So VLC, first, is not a media player, I'm very sorry. It's a media framework that has a very small core named libVLC core. I'm sorry for the name, we don't have good ideas. Above it, there is a library that helps you attack the core. And then you have modules that do mostly everything. A decoder, demuxer interface, I'm going to explain all those. And the core is maybe 80,000 lines of code. I mean, it's not much. We've seen way bigger. And the modules are maybe 500,000, but they also depend on 50 or 60 libraries, and that's around 10 million lines of code. So why is this great and why did that help VLC? The first reason is that having modules allows you to have a lot of formats, because the core does not know anything about codecs, like not a thing. It just knows about networking, memory management, thread management, and maybe audio-video sync. That's it. Everything is done by a module. So if you come with a new format, you don't have to understand how VLC works. You just need to do one module. And this helps you to do DivX, Matroska, Real Player, and all those. With that, it helps people actually use one player to work everywhere and play a lot of stuff. So that's one of the main things that help module, is that you can add a functionality in VLC without understanding the core, and that's good. The second reason is that VLC, so lots of people in multimedia use C, and we use, of course, C, but one of the main things was used in VLC, so in 1998, was what we call C object, or C minus. So it's something very horrible, where you can, where you abuse structs and command members and function pointers to get around the same ideas as C++. So, for example, this is the idea. I'm sorry if it's too small. This is audio output structure. So the code just does that, but it does not implement anything. But when you're going to do a new audio output, you're going to implement just the right functions. And with what we call opaque members that are used by the core, but the core does not know how to use them, you can implement modules in a very fast way. And that's good also because you don't have to use C++, which at the start of VLC was quite slow to compile and to use. It's not true anymore. But also, C, having a base in C helps us to have integration with C++, because we have C++ in the core, Objective-C, I lost the mic, Objective-C and assembly and Lua. So having this very strong base in C, but augmenting it to do a media framework was really cool and helped us getting modules. And with both modules and C, the C object, it helped us to port VLC everywhere. The last version of VLC works on OS 2. That was an addition to the last version. There is almost 15 users in the world. Oh, maybe 51. But it's really cool because you doing that, you don't. You can have abstraction done by the C core, and you can use the best technology ever in each platform. So the video output on Windows is using DirectX, and the macOS video output is not using DirectX. It's using, of course, Cocoa, and the Linux one Xvideo. And that's great because you don't have to select the one technology that works everywhere, but you take the best one on each platform. And that's important. A lot of media players took the ideas, hey, let's do OpenGL because it works everywhere. Wrong. OpenGL is the one thing that does not work everywhere at all. It's very difficult because every implementation is different. And I'm not only speaking about the one on Windows, but everywhere. So modularity and abstraction done by C help us to be everywhere. And being everywhere and playing everywhere, everything help us to have a strong brand that make us popular. And the last reason is what we call network-oriented. So the ideas for VLC was to be the client of the VideoLAN solution in the Central Paris campus, right? And on a network, you don't know what's going to arrive, especially when streaming. So you cannot go to the end of the file because, well, you know, there is no file. So you take the data when it arrives. That seems obvious when you do a network-oriented player. But the good thing is, for AVI or MPEG-4, where the metadata is at the end of the file, well, VLC was done to play without the end of the file. So in 2003, you're on Emule. Oops, never existed, right? And you download your latest movie, but with every media player, you need to wait for the whole movie to check if it's not porn. or if you're downloading porn to check it's not a Disney movie, or anywhere. Well, you get the idea. So the great thing is that VLC was able to play broken files or incomplete files very quickly, and that was huge because you download 20 megabytes and you still see 1 or 2 images or 30 seconds, and that was interesting enough. So this is usually the video framework, the VLC graph of the video framework that is VLC works almost like every other one, QuickTime, DirectShow, GStreamer, except that you're going to see that, so here is a format opener, which is a module. Here is a protocol that is also like the access, HTTP, FTP. Format is MPEG-4, AVI, MKV, and so on. And then it spawns different codecs, and then it outputs. The difference between VLC and the rest is that you see that the data, the arrows are in the opposite way, starting from the format. Because basically what VLC does is that it's a format opener that tells the protocol to buffer and say, oh, I'm out of the data. What it means is that when you download a YouTube video, it just goes in at the most and the fastest to download the whole movie and play it. And of course, a lot of time it does not work. So you have to tweak a lot the servers to have like a constant with a peak. And if you're with free, you don't have any data at all. But VLC does not do that. VLC does a constant caching. So for example, your MKV demuxer says, oh, I need more data. And you have a constant amount that is based on the number of seconds. So VLC is going to download 1 second over HTTP, and that's the default. And it's never going to download or eat your bandwidth more because it does not need more. It just needs the next seconds. And it's going to adapt, but not too much. So that's the third thing, and that's inherited by the VLC heritage, which was we are focused on networking. So networking helped us to play broken files, but also to not use amount of bandwidths that are useless if you're not going to watch all the file. And the other thing is being network-oriented helped us to develop all the streaming capability inside VLC. Thank you.